Hello everyone, this video is about operations of complex numbers and geometrical effects. Addition and subtraction in Cartesian form. Just add or subtract the real part with the real part, the imaginary part with the imaginary part. For example, 2 plus 3i plus 4 plus 4i. Add the 2 and the 4, the real parts, we get 6, and 3i plus 5i is 8i. For subtraction, same thing, minus 6 minus 8, which is 2, minus 7i minus 9i, which is also 2. And if you want to add or subtract complex numbers in other forms such as polar or exponential, just convert to Cartesian form first. For example, here we have 8e to the power of pi over 4i. We use 8 cos pi over 4 plus I sine pi over 4. We get the Cartesian form, and then we can subtract or add. Alright. After we add or subtract the real part for root 2 minus 2 root 3, we can combine the real parts and the imaginary parts like this. Multiplication in Cartesian form, just use the rainbow method. We expand 1 by 1, 4 root 2 times 2 root 3, we get 8 root 6. 4 root 2 times 2i, we get 8 root 2i. 4 root 2i times 2 root 3, 8 root 6i. 4 root 2i times 2i, 8 root 2i squared. And remember that I squared is minus 1, so we have minus 8 root 2. And in the end, we get 8 root 6, the real part, 8 root 6 minus 8 root 2. The imaginary part, 8 root 2 plus 8 root 6. And multiplication in exponential form, we multiply the moduli and we add the arguments. So for example, 8e to the power of pi over 4i times 4e to the power of pi over 6i. We multiply the moduli, 8 times 4, we get 32, and we add the arguments pi over 4 plus pi over 6, we get 5 pi over 12. And if you convert this to Cartesian form, actually you will get exactly the same as this Cartesian form. And if you convert this to Cartesian form, you get this. So actually we are doing exactly the same multiplication in two different forms, and of course the results should be exactly the same. So if you use your calculator here, 32 cos pi 5 pi over 12, you will get 8 root 6 minus 8 root 2. You can try. And 32 sine 5 pi over 12 equals this. Actually, division in Cartesian form, we use the conjugate method, which is similar to rationalizing denominator. So here we have plus 2 root 3 plus 2i. The conjugate or the complex conjugate is 2 root 3 minus 2i, because when we multiply the denominators, we will cancel out the I in the end. So here we just use the rainbow method. We expand, we get this in the numerator, and in the denominator, if we expand 1 by 1, the terms with I will cancel out. We have only a simple real number without I in the end, and you can collect the like terms, the real and the imaginary part, like this. And if you use exponential form, we divide the moduli and subtract the arguments. So here 8 divided by 4 is 2, pi over 4 minus pi over 6 is pi over 12. And again, we are actually doing exactly the same division. This complex number in Cartesian form is the same as this complex number in exponential form, same thing as the denominator. And so if you try with your calculator, 2 cos pi over 12, you will get this. and 2 sine pi over 12, you will get this. Now the geometrical effect of adding complex numbers. So basically it's a translation. So if you have 2 plus 3i, so this point is 2, 3, plus 7 plus 2i. So this is just like transformation, a translation. So you just slide or move the point 7 units to the right, 2 units upwards. Or you can say it's like a factor addition using the parallelogram method here. And for subtraction, it's also translation but in the opposite direction. So it's like a factor subtraction. So we have 2 plus 3i again, same example, but this time we subtract. So instead of going in this direction, same direction as the red factor, we go in the opposite direction. Alright, now complex conjugates. So if this is the z, the complex conjugate is called z star with this asterisk symbol. So plus 2i for the original, minus 2i for the conjugate. So of course it's a reflection in the x-axis or vertical reflection. And the geometrical effect of multiplying, it's a stretch and rotation. So for example, we have 4 cis pi over 6 multiplied by 2 cis pi over 3. What we get is 4 times 2 we get 8, and pi over 6 plus pi over 3 we get pi over 2. So this is the result. So as you can see, the length is the product of the moduli, 4 times 2, and the argument is the sum. So the pi over 6 plus pi over 3. So we rotate according to these 2 cis pi over 3. So pi over 3 in positive means in this direction, counterclockwise. And we also stretch by the scale factor 2 in this case. When we are dividing, it's almost the same, but the factor is smaller than 1, so it's a compression, and the rotation is in the other direction. So 4 cis pi over 6 divided by 2 because of 2 cis, and minus pi over 3 because we divide, so we subtract the arguments, and this is what we get. So the length is halved and the argument is rotated pi over 3 clockwise direction here. And last one, so this is an example. If we have 4 plus 3i times I, well, I is actually 1 cis pi over 2. So this means the length is exactly the same because the moduli here is 1. We multiply by 1, so the length is exactly the same, but we rotate 90 degrees in positive direction or counterclockwise direction. So this is what we get. This is the original, and this is the after we multiply the product, the result of the multiplication is the green one here. And if we divide by I, that is the same as dividing by 1 cis pi over 2. So the moduli exactly the same because we multiply by 1, but the angle we do 90 degrees clockwise because divide we go in the opposite direction, clockwise direction. So this is the original, and this is the result after the multiplication, after the division actually. Alright, I'll see you again next time.